Here's an example where a ratio test is easier to compute. As you can see, factorials usually means you want to use ratio test. Okay. So our AN is 5 to the nth power over n factorial. Now let's think about what AN plus 1 is. You replace all the n's by n plus 1, right? So you have n plus 1 here, and plus 1 here as well. Before we actually do the ratio test, let's think about what happens to this series. When n is really large, which one's bigger?
The bottom.
Oh wait.
The bottom's a lot bigger. So if you have 100 factorial, right?
Oh, sorry. I was thinking of
Yeah,
just
yeah,
n.
yeah. 100 factorial is like 100 times 99 times 98. Whereas on the top, 5 to the 100th power is like 5 is multiplied, right? But if you look at this, when eventually it becomes 4, 3, 2, 1, these are the only, or maybe 5, these are the only 5 cases where it's less or equal to what's multiplied on the top. But afterwards, this totally outperforms the top one, right? This makes it, like multiplying by 100 is much bigger than multiplying by 5, right? So the bottom one is much, much bigger as n goes to infinity, right? So in fact, you could show that this converges by showing that this is less than 1 over n squared at some points for some bigger n values. So when n is like 10 or more, then you can show that this is less than 1 over 100 and 1 over n squared. That requires a little bit more calculation, so it's not easy. Okay? And that's why you want to use ratio test. Ratio test makes things a lot easier. You don't have to think about another thing to compare with. Okay, so now let's take the ratio and take the limit. Limit n going to infinity. AN plus 1 divided by AN is limit n going to infinity of 5 to the n plus 1 over n plus 1 factorial divided by 5 to the nth power over n factorial. Now, you have a fraction divided by fraction. You keep the top, change the division into multiplication, and you flip the bottom. So it's keep, change, flip. And you have to take n to infinity. And once you have that, you see that it's easier to make this into a product of 5 to the n plus 1 divided by 5 to the n times n factorial divided by n plus 1 factorial. That's because this is very simple. What's that?
Just 5.
It's just 5, right? You have to, when you divide, the exponents subtract. What's n plus 1 minus n? 1. So that just equals to 5. Now, the problem is this one. What does this simplify to? And actually, because I don't want you to just accept what I just say, I'm going to give you a 1 minute of silence, okay? So 1 minute of silence, and everyone think about what this simplifies to. Don't say a word. Yeah, but the question is, how do you think? How do you know what to do in order to simplify this?
Extend it.
And I say this because even with 12 years of education through your high school, nobody really taught you how to think. And I actually want you to know how to think. When you see something abstract, you want to make sense out of it by thinking of examples. So think of some small number, say n is 3. In that case, you have 3 factorial divided by what? 4 factorial. And then what does 3 factorial mean? 3 times 2 times 1, right? What does 4 factorial mean?
4 times 3 times
4
2
times 3 times 2 times 1. How can you simplify this?
Cross out the 3 times.
And you get 1 over 4. Yeah, you get 1 over 4. Now once you do this example, then you see what should be done here. What is this?
1 over n plus 1.
Yeah, because n factorial is like n times n minus 1 times and so on, right? N plus 1 is like n plus 1 times n minus 1, so on, until it reaches 1. So this much and this much will cancel out, leaving you with 1 over n plus 1. Okay? Yeah. Now, for those of you who weren't thinking anything at all, why weren't you thinking?
Exclamation point.
Why weren't you thinking? You probably didn't know that you can do this, right? Yeah. And basically, a lot of you have the mode of thinking that, oh, thinking means you remember. But that's different. Right? Remembering something that you learned in the past is not the same thing as thinking. By thinking, you can actually figure things out you're not taught. Okay? And you can save yourself a lot of trouble by thinking. Thinking, you can just do this. Just think of examples and you can figure it out, right? Okay, so here's what we find, that limit n goes to infinity. This will be 5. And then this is 1 over n plus 1. So that you have limit n going to infinity of 5 over n plus 1. What's that?
0.
0, because n goes to infinity, that's 0. Which means
Convergence.
convergence. So the answer is that the series converges by, and on your exams, please write down what test you used. Okay, so the series converges by
Ratio.
ratio test.